Okay, so here we go. 2.7.1. We are talking about rational functions. Do you get that a rational number is a number that can be written as a fraction? Did you know that? If you didn't already have that memorized, maybe you should write that down. A rational number can be written as a fraction. So for instance, 2/3, of course, it already is a fraction. That's rational. Can you take the number 5 and write it as a fraction? Yep, so that's rational. What's something you can't write as a fraction? Can you name me anything you can't write as a fraction? Yes? Imaginary numbers you can't write as fractions. Okay. Give me something else. 0 can be written as a fraction, believe it or not. 0/0. Yes? You can write repeating things like 1/3. 1/3 is 0.3 repeating. Pi is different because that doesn't repeat. So what you're trying to think of is something that never ends. Okay, never ends. Something like pi. So pi is irrational. Everything else is pretty much other than pi and things like the square root of 2, square root of anything that doesn't work out nice, like square root of 10, square root of 11, anything that doesn't, square root that doesn't work out nice, those are all irrationals. You can't write them as a fraction, other than, of course, putting it over 1, but that's kind of cheating. That's not really making it into a normal fraction with two numbers. This one's got a square root on top still. So anyway, rational numbers can be written as fractions. So obviously, these are pretty much rational equations like this. 2 plus 5 over x is equal to 12. And this one's really pretty easy because we've been doing that top 20 so long that I hope you're like, God, clearing fractions, that's easy. What do you do? Times by, what'd you say? Times by x, you're right. I times this by x, times that by x, and times that by x. I times everything by the denominator. Okay, and then this one cancels this one. And I have 2x plus 5 equals 12x, and we don't even need to solve it from there. I mean, it's so easy. You guys can handle that without any help, right? So yeah, you can figure out what x is, like, easy peasy from here. Minus 2x, minus 2x, 5 equals 10x, divided by 10, x equals 5/10 or 1/2, okay? Now, it can get a little more complicated, of course. What if you already have an x in there, and then you multiply everything by x? How are you going to multiply by x if there's already an x there? You can do it. Just becomes what? 5x squared plus 1 equals 3x. And then you'd subtract 3x. Why am I getting everything onto one side? Because this is a quadratic. And you remember how to solve quadratics. If you can't factor them, then you quadratic formula them. Now this one, I don't know if it factors or not, but I can tell you this, it'd be a pain in the neck to try to factor even if it did work. 5x and x, and then be a 1 and a 1. Let me think now, and they'd have to both be negative, so I can have a negative middle term, and yeah, bottom line is it doesn't work. So how am I going to get the answer if it couldn't factor? Quadratic formula. So if that's x equals negative b, it's positive 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 5, times 1, all over 2a, which is 2 times 5, which is 10. And I know you know how to do quadratic formula. So this is all stuff you already know. We're just kind of putting things together that you already know how to do. You already know how to clear fractions. When you do clear fractions and you get a quadratic, you already know how to solve quadratics, either by factoring or quadratic formula. All right, so it's really not too rough today. I'm going to challenge you with one other thought, though. You can solve these things by graphing. Let's make it 4 over x, like we were. 4 over x equals 2x. For instance, this one. This one, if you multiplied everything by x, it would become a quadratic, and you could solve it that way. But if you had a choice, and you had a calculator, wouldn't it be pretty easy to graph both sides of this and see where they cross? Let's do it that way, because part of your worksheet for today requires you to graph them and solve them. So grab a graphing calculator, just type it in. I'll pause for a second while I get it typed in on mine. Okay, do you have to have that 4 over x in parentheses? No, but I strongly recommend it because whenever you put in fractions into your calculator, there's a chance your calculator is going to do the wrong order of operations on you. And it's best to just always make it a practice. Whenever you put in a fraction, put in parentheses. All right, now 2x. And now hit graph. And I should get 2 lines. Oh, that's interesting. Wait a minute, there's 2 possible answers? Think about it. If it was going to be a quadratic when it came out, do you get quadratics that have 2 answers too? All right, so it's okay that it has 2 answers. So how do you do the answers? Do second, calculate, intersect. And here's the thing though, if you just hit enter, 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 you're always going to end up jumping to the same one. So we have to understand what's going on here because first curve, it has the little spider on one of the 2 curves. There, I can see it now. It's on that curve. Enter. Second curve, enter. Guess, I'm really close to where I want to be here. Close enough. Enter. And I get negative 0.63 is my x. Now, how do you tell if you want x or y? Look at the equation. Does the equation even have a y in it? So are we trying to find the x? Does that make sense? All right, so we just want to find negative 0.63, and if you want to use 3 decimal places, negative 0.3637. Okay, now on the other one. Second, calculate, intersect, and then first curve. I'm going to get closer now to the other one, and I'm like, wait a minute, I can't get over there. How do I get over to that other one? If I hit up arrow, I can get on to the other equation and kind of ride it up there. Now I'm going to get close to there and say first curve, enter. Now when it says second curve, it jumps right next to it onto that curve. And then guess, again, you always just go over to right about where they cross. There we go, 3.137. All right, so basically you're just graphing both sides, seeing where they cross. Remember my advice about the fraction and always putting it in parentheses? You're going to have a lot of fraction functions today. And when they ask you to check them with the calculator, just take the extra 2 seconds and put them in parentheses. Okay, because it'll really increase your chances that your calculator won't do the wrong order of operations on you. Okay, so I think we should actually go look at the homework together. That's 2.7.1. I'm going to pause for a second while you all find it. 2.7.1. Okay, so here it is, 2.7, number 1. Solve the equation algebraically. So we got to get rid of that 3 that is pesky denominator on everything. So you just times by 3 everywhere. And then this will cancel this will cancel that, and that'll cancel that. And be careful now. If this was a multiply problem, they would need parentheses on the top of that equation. Get what I mean? Remember that fractions always have parentheses around the top and around the bottom. If it's a single digit, like here, do you get that the bottom doesn't need parentheses? It's just a 3, but the top does. All right, so why does that matter? Well, in this case, it doesn't because it's an add problem. So I've just dropped the parentheses anyways. But if it had been a multiply problem, and there will be ones you'll run into like that, you'd need to know that. Okay, so anyway, I've really got x minus 2 plus x plus 5, and that equals 3. And again, you can't solve that with solving with a little equation. I'm scared for you. That's just basic algebra. All right. We are getting ready, though, for a big old honkin' algebra test. And you remember how algebraic manipulation tests are the hardest ones by far? You just had 2 tests last 2 days. Okay, so the next test is on algebraic manipulation. That's the hard kind. It's going to make up for how easy those last 2 were. Okay? So these are the first ones. These will be like R2 kind of questions. These are, you know, you might see something like this, but it will be one of the easy ones. We're going to get to some challenging algebra. All right, so if I was going to solve this one, I've got an x on the denominator, so therefore I'm going to multiply everything by x, 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 and x, and then this one will cancel this one. and I'll have an x times x is x squared plus 2x equals 15. Move that to the other side, and then if it won't factor, say it. Quadratic formula. All right. Now let's move down to some of the other, a little bit harder kind. Clearing the ink. Which one is clear the ink? I think it's that one. Okay, so then scroll. Come on. Okay, fine. Grab the scrolly bar on the side. And let's look at this. It says, then check them graphically. So in other words, you're going to solve this by hand, the old-fashioned way, and then you're going to grab your calculator, graph both sides, and see where they cross. So what's my first step? Get rid of the x. How do I do that? Times by x. Okay, good. That cancels that. X squared plus 10 equals 7x. Can I factor it right now? Not quite yet. First, though? Yep. Now I can factor it. And I think this will factor because it's got a 5 and a 2 make a 10, and they also make a 7. You got to multiply to this and add to that. So I think this is going to work. So if you can factor it, yay, so much easier. X and a minus, because that way it'll make a positive 10. 5 and a 2, and I just got to check now. First, make x squared. Outside makes negative 2, inside makes negative 5, makes a total of negative 7. Yay. And the last make positive 10. Cool. The answers are 5 and 2. How do I check? You graph it, and you make a little sketch for me to prove you graphed it. Okay, so when he says check them graphically, I want to see a little sketch, because it's not going to look anything like this. Okay, this little 10 over x part is probably going to be that, you know, this kind of a deal. And then it's going to have a line running through it that'll probably touch it twice. And where do you think it's going to touch it? 5 and 2, probably. Okay, so the way I just did it probably wouldn't be how it looks. It probably is going to be more, touch it at 5 and 2. Let me think how that could look. Maybe it's going like this, touching it at 2 and 5, something like that. Anyway, you'll have a straight line connecting with a curve. You'll get 2 answers. Hopefully they'll come out to 5 and 2. All right, let's move on. Clear this off. Move this down. Ooh, that looks a little scarier. Let's look at number 11. Let me see if that is actually a 2. Is that a 2 or is that a 12? My red line's covering it. It's a 2? Okay. So then, I'm going to multiply everything by, what do I multiply everything by? Well, you got to figure out if x plus 1 alone would do it. And it wouldn't. Because that would clear this denominator, but it wouldn't clear that one. Do you remember how if there was 2 things to get rid of, you had to multiply by both of them? Like, remember, if we had like x over 5 plus x over 3 is equal to 12, you'd multiply everything by 5 and by 3. You know what I mean? You'd multiply by both things. So somebody, tell me something smart you could do here to figure out what to multiply everything by. Yes, ma'am? Yes, x squared plus x factors. And you remember my little saying, if you can factor it, you should? I can factor that, so I should. X comes out, and then I have x plus 1. Now do you see the 2 things that you should multiply everything by? Well, obviously, this one's got an x plus 1, this one's got an x plus 1, so obviously x plus 1 is one of the things I should multiply by. And, come on. Yeah, x. Multiply everything by x and by x plus 1. So if you multiply this side by x and x plus 1, that'll make the denominator cancel. I multiply this part right here by x and x plus 1. That'll make the denominator cancel. And you multiply this part here by x and by x plus 1. How does that look? Well, it ends up being 2 times x plus 1. That's really 2x times x plus 1. You can do that. Just FOIL it out, or not FOIL it, just distribute it out. No big deal. And then this part right here was minus, and these parts canceled, so it's just 1 times x. X equals, and then there's this part here, and since all of that cancels all of that, I just have a 1 left. And from there, it's a nice simple equation. So the only thing that was hard was figuring out what to multiply everything by. Same in this problem. I'm going to have to multiply everything by something. And remember my advice that if you can factor something, you should. And that helps you to see what to multiply everything by. All right. And that's all the advice I have for you for today. Enjoy the easy part, because this is going to get more challenging. We're going to have probably 6 or 7 or 8 days of new stuff before we get tested. So that's going to make it definitely more challenging by the end. So stay caught up. Get your homework done every time. The test is not next week. The test is actually after you get back from break.
Right after?
Not the day after. We will have a couple days of review and then the test. So yeah, it's kind of a little bit unfortunate. If we had 3 more days before break, we would test you, but you just don't have enough time to teach you all of it and review it and test on it. So we're teaching you almost all of it. When you come back, we just learn one more little thing, and then you have a couple of review days and the test. And then you have a couple of review days, and then, or a review day at least, and then the cumulative test, which covers the 3 tests. From there, it's pretty much all review for the final, the semester 1 final. So basically, we're 1 little unit away here from being at the review for the final. So, okay, that's all I got for the video for today.